Hydrogen cars, also known as hydrogen fuel cell cars, are a type of passenger vehicle separate from electric cars. Hydrogen-powered cars are more similar to electric cars in the fact that they have no internal combustion engine. Although hydrogen cars can rarely be seen on the road, it all comes down to which one is better, hydrogen or electric. Here is everything you need to know about hydrogen cars and whether they are better than electric cars. To get the juiciest facts, make sure to watch the video. Now let's get down to it. Let's get the main question out of the way first. What is hydrogen? Before going into the technical details and comparing hydrogen and electric car technologies, let's first look into what hydrogen and electric cars are and how they work. Hydrogen is the most abundant element on the planet, having powered engines as long ago as 1807. It's also the cleanest kind of fuel out there. A hydrogen fuel cell car has a hydrogen tank that feeds a fuel cell with high-pressure hydrogen gas that mixes with oxygen. This mixture starts an electrochemical reaction that produces electricity, which is then used to power an electric motor to propel the vehicle without any toxic tailpipe emissions. In fact, the only byproduct of the whole process is water and heat, which is produced as a result of the connection of hydrogen and oxygen atoms that form water molecules. This means hydrogen cars have characteristics of both electric cars, due to the use of electric energy, electric motors, and the lack of an internal combustion engine. While conventional petrol cars have a tank, fuel cells are the main component of hydrogen-powered cars. Now, what is electric? You can think of them as the maestro of all the processes happening inside the car, so that it has the energy to move. On the other hand, an electric car is powered by a lithium-ion battery, which supplies power to an electric motor to power the various parts of the vehicle. The batteries are recharged by plugging into the electricity grid, much like any other electric device such as a computer or phone. Some types of electric cars can also provide themselves with a small recharge when braking by converting the heat that is produced into electricity. Now, with the basics out of the way, it all comes down to which one is better. But before concluding, let's look into and compare the important characteristics of each type of vehicle. Hydrogen versus electric. Energy efficiency. Hydrogen is inefficient because it doesn't occur naturally. It has to be extracted and then compressed into fuel tanks. In the process of converting the hydrogen fuel to electricity, most of the energy is lost because the energy must move from wire to gas, then to wire to power a car. This process is called the energy vector transition. Taking 100 watts of electricity produced by a renewable source, such as a wind turbine as an example, to power a hydrogen fuel cell car, that energy needs to be converted into hydrogen, possibly through the process of electrolysis, which means passing it through water. This process is 75% energy efficient, so 1/4 of the electricity is automatically lost. After getting the hydrogen, it further needs to be compressed, chilled, and transported to the hydrogen station, and all this process is about 90% efficient. Also, once inside the vehicle, the hydrogen is converted to electricity by the fuel cell, which is 60% efficient. Finally, the electricity is used by the electric motors to propel the vehicle, which is 95% efficient. Putting all these together, only 38 watts of the original 100 watts of electricity are used. On the other hand, the energy to propel electric vehicles comes straight from the battery pack. Unlike hydrogen fuel cell cars, the energy runs on wires from the source to the battery. The same 100 watts of power from the same turbine loses about 5% of efficiency in this journey through the grid. It further loses 10% from charging and discharging the lithium-ion battery, and another 5% from having the electricity power the electric vehicle that propels the car. So you're left with about 80 watts, as compared to 38 watts with hydrogen fuel. It is clear that hydrogen vehicles are less efficient than electric vehicles. Hydrogen car refueling stations versus electric car charging stations. There are over 10 million electric vehicles on the roads worldwide, and sales have been rising strongly. They will continue to rise. The number of powering stations for electric vehicles is growing every day as the number of electric vehicles increases. There are more than 40,000 electric vehicle power stations in the US alone, compared to just 45 hydrogen refueling stations. Governments around the world have been investing in infrastructure such as charging stations at existing petrol stations, motorway rest stops, shopping center car parks, and even on the side of some streets. The United Kingdom also offers grants towards the purchase and installation of domestic charging points. In addition to its efforts in passenger vehicles, Ford is also taking a leading role in investigating the potential use of hydrogen as an onboard energy source for its highly regarded e-transit and all-electric commercial vehicles. This reflects a broader commitment to exploring sustainable and environmentally friendly transportation solutions in the commercial sector. In collaboration with the Advanced Propulsion Center and other key partners, Ford has initiated a research project in the United Kingdom to explore the potential of hydrogen fuel cell technology in extending the driving range of the e-transit, especially for customers with high energy-intensive needs. Partial funding from the Advanced Propulsion Center has allowed Ford to form a consortium comprising 6 automotive technology leaders and fleet operators. Together, they will assess the essential hydrogen refueling infrastructure required to support this groundbreaking technology. Ford Pro, the division specializing in commercial vehicles and services, will leverage this pilot program to expand its expertise in on-site vehicle conversions. Ford's engineers and e-transit specialists from their Dagenham site and Dunton Technical Center in Essex, UK, will provide crucial support throughout the project. Tim Slatter, chair of Ford in Britain, emphasizes Ford's vision of applying fuel cell technology to its largest and heaviest commercial vehicles, ensuring they operate emission-free while meeting the substantial daily energy demands of their customers. This initiative aims to make clean deliveries viable even for the hardest-working vans on the road. Ford's hydrogen fuel cell e-transit project involves a collaborative effort with specialists in fuel cell powertrains and fleet operators, including Ocado Retail. Partners such as BP will analyze hydrogen usage and infrastructure needs, Veritech will design hydrogen storage systems, and Signatech Kim will provide carbon fiber tooling for the pressure vessels. Ford has been actively researching fuel cell technology since the 1990s, continually developing prototypes and fine-tuning test vehicles in collaboration with customers. In 2021, they showcased a fuel cell-equipped e-transit vehicle on a broader European scale. Ford participates in publicly funded projects exploring hydrogen technologies for both internal combustion engine-powered vehicles and fuel cell vehicles. As part of a 3-year project until 2025, Ford will deploy a test fleet consisting of 8 hydrogen fuel cell-powered Ford e-Transits, each running for 6-month periods. The data collected will provide valuable insights into the overall cost and operational feasibility of using a large van with an extended zero-emission range, rivaling that of diesel-powered equivalents. These prototype Ford e-Transits will be equipped with high-power fuel cell stacks and significant hydrogen storage capacity, carefully optimized for safety, capacity, cost efficiency, and weight considerations. Sustainability is a key focus, including assessing efficient and practical recycling methods for end-of-life components, contributing to a more sustainable future in alignment with Ford's road to better sustainability commitment. The hydrogen-powered e-transit project demonstrates the company's dedication to making its European operations the first region to achieve carbon neutrality by 2035. Ford has already achieved a significant milestone by reducing emissions from its worldwide manufacturing facilities by 40% since 2017. Ford's commitment underscores its efforts to contribute to a more sustainable and environmentally responsible future. While the debate between hydrogen and electric vehicles rages on one thing is certain: innovation knows no bounds. Ford's relentless pursuit of cutting-edge technology is shaping the future of transportation in a world where change is the only constant. The possibilities are endless, and one thing's for sure: the journey is bound to be electrifying. So buckle up and stay tuned, because the road ahead promises to be nothing short of exhilarating. If you found our video informative, kindly like our video and subscribe to our channel.